Hello everyone, my name is Josue Twahigo. I'm going to talk about the summary of my first assignment of statistical machine learning. Uh, as you say, I was having the dataset to study about the dataset called SML. So it contains two variables where one predictor and one response variable. It also contains the 225 observations. I studied the scatter plot of it to see the relationship between x and y as predictor variable and response variable. I have seen that there is noise, some level of noise or variability of data. Uh, Also, I have seen that it's reached to the maximum. Y reached to the maximum when x is equal to negative 0 point negative 5. So I have studied the machine. I was trying to build a machine that will help me to study easily my data set. I have defined the polynomial of degree p. Uh, it's non-linear, as you see. The data also, they are not linear. I have defined the function, the loss function, to measure the error between the observed value and the predicted values. As you see also, I was having the part of estimation and the model complexity, where I tried to find the value of beta such that I will be having the minimum value of error to minimize the error. So I ended with this value of beta. This one was a value of beta, so that I replaced in my f the new variable f to get this stuff. So I studied also the cross validation of data, where I've seen the degree at degree of 1 and degree of 2, the data was underfitted, and when it started to reach, when p is 10 or more than 10, the data becomes overfitted. So we're here requested to find the optimal solution to our model. So I have created it, the cross validation error and this empirical risk error. So I continued with performing the stochastic validation due to training. I divided the data set into two parts: 70% and of training and the sort of testing. So let me go ahead with the question 2 exercise 2, where I was having a built-in dataset called spam. It was a categorical regulation because the response variable was taking two values, non-spam and spam. It was containing the dimension, or it was about 4,601 for rows, and columns was about 58. So as you see here, I tried to use uh, this method of comparative model to compare the learning machines, a linear discriminant analysis, quadratic discriminant analysis, and all those four models, to see how they performs, how they fit the data. So as you see here, I have seen that the with this LOC curves linear and the left corner, you have seen all four models achieve the high sensitivity and specificity of my data, and I have seen that since this FRD is a variation of linear discriminant analysis, is not surprising that the FLD and the LAD curves almost are the same. Sometimes it looks like the same, but quadratic, it handles the non-linear boundaries. It performs the marginal better as well as those one. So I also plotted that comparative model plots to see how the best are. As you see here, we can say that From this, we can say that the test error distribution shows that simple models such as FRD and LDA are consistent. So thanks for this presentation. Thanks for attention.